In this video, I'm going to show you how to prove trigonometric identities using the sum and difference identities or the double angle identities. Let's start with the first one. We want to prove that sine 2x over 1 minus cosine 2x is the same or equal to cotangent 2x. So in proving, we start usually with the side that is more complicated. Some people will do it one side or one-sided proof. Others will do it using the two-sided proof. In this presentation, I'm going to show you a one-sided proof. Okay, so let's write the word proof to start the proof. And the more complicated side is the left side. So I'll be copying the left side, sine 2x over 1 minus cosine 2x. And I need to think of an identity that can replace sine 2x. So take note that sine 2x is the same as 2 sine x cosine x. And the denominator is 1 minus cosine 2x. Cosine 2x has three identities. Cosine 2x can be cosine squared x minus sine squared x, or it can be 2 cosine squared x minus 1, or 1 minus 2 sine squared x. So in proving, you have to determine which of the three will be the best in this case. My suggestion is avoid cosine squared x minus sine squared x, because that will give you a cosine and sine at the same time. And usually this identity is used whenever you have cosine minus sine or cosine plus sine in the numerator. In this case, we don't have that. So you can either choose the second one, 2 cosine squared x minus 1, or use 1 minus 2 sine squared x. Actually, either of these two will work. Suppose we decided to use 1 minus 2 sine squared x. 1 minus 2 sine squared x. You will notice that after doing that, and if we simplify this expression, this will become 1 minus 1, and eventually 1 minus 1 will be 0, and that will be a good option. On the other hand, if we use 2 cosine squared x minus 1, you will have 1 minus negative 1, which will become 2. It's not that difficult to simplify, but I think in this case, 1 minus 2 sine squared x will be better. Okay, so to continue the proof, so just simplify what you have now. So 1 minus 1, negative, and a negative. So take note that the parenthesis is very important when you replace an expression. Error are sometimes committed because of not putting a parenthesis when substituting an expression. So to continue, this is 1 minus 1 plus 2 sine squared x. Then continue simplifying the expression. So we now have 2 sine x cosine x over 1 minus 1 is 0. So you have 2 sine squared x in the denominator. So you can see, you can cancel 2 and 2. That means 2 divided by 2 is 1. Sine and 1 of the sine in the denominator. So you're left with cosine x over sine x. And we know that cosine x over sine x is equal to cotangent x. So we were able to show that this expression is equal to cotangent x. Therefore, we have proven that the two are identities. Okay? Okay, so the second is cosine 90 minus x is equal to sine x. Now, how do we show that these two are the same? We start the proof by writing the word proof, and then when you look at the left side, you should be able to recognize that this is in the form of cosine A minus B. The right side is in simplest form, so the best way to prove this is to simplify the left side. So if I use one-sided proof in letter A, I'll be solving this using two sides or two-sided proof so that you will see the difference. Although you can always use one-sided proof. So in the two-sided proof, so let's just make a note. So two-sided, we copy the identity 90 minus x equal to sine x. So we are still proving it, so you put a question mark. And then simplify this using the identity. So as a note, cosine a minus b is cos sin ab, and if this is minus, it's the opposite sign, so this is plus. So cosine 90 minus x is equal to cosine 90 cosine x plus sine 90 sine x. We want to show that this is equal to sine x. But we know cosine 90 is equal to 0. So 0 times cosine x. And the value of sine 90 is 1 times sine x equal to sine x. Any number or expression multiplied with 0 will become 0. 1 times a number or an expression will be the same. So this is sine x. And then we want to show that this is equal to sine x. But 0 plus sine x is equal to sine x. So the two sides are now the same. Since the two sides are now the same, we were able to prove that cosine 90 minus x is equal to sine x. So that's the proof for this identity. Okay, so we're done.